Hello. Today we're going to talk about an EDA related topic that is just as important as all of the technology represented by those standards, and that is the ways of creating a good purchasing specification for EDA. This presentation is targeted, of course, to the actual factory people that will be specifying EDA to be delivered in the equipment that they purchase, and so but it could also be useful to the tool suppliers to understand what to expect when an EDA purchasing specification arrives. As we said, EDA is a complementary standard to the GEM command and control standards. It is focused on the high-speed, flexible, on-demand data collection requirements, and the need for more and better data in flexible ways has grown exponentially over the last years, and so we see there'll be increasing demand for EDA interfaces, and the best time to actually get your purchasing specifications right is early on in that process. The simple way to summarize it is that you will get what you specify, no more, no less. So it's important to understand what should be in a good purchasing spec to make sure that your expectations are well understood and met by the tool suppliers. So, first and foremost, and a part that is frequently omitted from purchasing specs, is actually a section on the manufacturing objectives. The better the tool suppliers understand what you're going to be doing with this data, the better they will be able to provide interface technology that support those needs. You can't put everything in a specification. There's a lot of information that's between the lines, and a clearer understanding of your manufacturing objectives can help fill in those gaps. The second section would be, of course, just a list of the semi-standards, both the ones in the EDA suite as well as the ones that complement the EDA standards to make it a complete interface. Now, the EDA standards actually are probably 10 to 12 individual SEMI documents, and for each of those documents there are multiple revisions. Some of those revisions are not compatible with one another, so it's important to know what the consistent and compatible sets of those documents are so that you can specify a compatible set. Now, luckily they've been grouped together into what has been called Freeze 1 set of standards and a Freeze 2 set of standards as the most recent group, and the content of those freezes is well documented on our website, so you can go see what that is. But again, that's a list of the actual versions of the semi-component standards. Now, one of the most important standards in that suite is the E120, E125, and E164 standards. You'll remember those deal with the content of the metadata model. Now, the metadata model is important in EDA because that is effectively the contract between you, the chip maker, and the equipment supplier. If the information you want doesn't appear in the metadata model, you will not be able to collect it. And these things can't be modified easily, if at all, after a piece of equipment is developed. So it's important to make sure that you specify not only the specific standards that mandate what's in that model, but that you specify the extensions that are important to you and your company. And so making sure that the scope and content of the metadata model is crystal clear in your purchasing specs is important. Now, there are two ways that that model can be extended. Number one would be to support applications that are important to your competitive advantage, and we can't really predict what those would be ahead of time, but there are natural places in the metadata model to capture that information. The other dimension of extension is the process-specific one. You likely have in your current purchasing specs information that is unique to etch processes, to deposition, to lithography, to CMP, even to measurement equipment perhaps. Those same kind of process-specific extensions will have a natural place in an EDA specification. In fact, they could take as explicit a representation perhaps as a model template, and so you can be very specific about the parameters and events and exceptions that you want to see to support specific process applications. So that's Section 4. Section 5, of course, is performance requirements. EDA has moved the bar in terms of data collection volumes and rates much higher than the GEM era. but it's important to be explicit about how many parameters you may want to collect from equipment, at what rate, and for how long. So these are the important performance specifications you need to have. Also, availability, reliability, other aspects of the interface that are important to you should be in this section. And then last but not least is the testing section. So the conformance and acceptance testing, you should be very explicit about the scenarios you're going to use, in particular the integration between the GEM sequences and the EDA interfaces, as well as the acceptance testing scenarios you'll have. It should be also important to specify, if you know ahead of time, what software test tools you will use to perform those tests and what kind of reports you expect from those test tools. So you can see specifying EDA is it's not magic, but it is an important piece of work that has to be considered ahead of time, because once a tool is delivered, it's too late to renegotiate what goes into that interface. So Symmetrics has worked with the early adopters of EDA for many, many years, and the insights in this outline and the details underneath it have been derived over years of production experience, both with factories and many equipment suppliers. We'd be very happy to help you craft a purchasing specification based on this outline, specific to your factory needs. Just click on the link at the end of this presentation. Thank you.